take it ready. Hello everybody, welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and over here we are going to discuss that which formulae and concepts are important for you to revise when you move on to from grade 10 from grade 9. So are you guys ready for that? Hello Chain Life, welcome to this session. Am I audible and visible to everybody over here? So we are going to discuss over here the formulae and concept which you should do before you move to grade 10 if you are in grade 9 right now. Because I have seen that many students when they are in grade 10 they have issues in some of the concepts which they have studied. See, वैसे तो तुमको सारी चीजें आनी चाहिए, इसमें कोई डाउट नहीं है. अब क्योंकि मैथ्स है ऑब्वियसली थिंग्स आर रिलेटेड टू ईच अदर, राइट? सो यू कैन नॉट से कि पिक एंड चूज करोगे, लेकिन जो सबसे इंपॉर्टेंट चीजें हैं जो तुम्हारे टिप्स पे होनी चाहिए व्हेन यू मूव ऑन टू ग्रेड 10 फ्रॉम ग्रेड 9. सो सबसे पहली चीज विच यू कैन सी ओवर हियर इज लॉज ऑफ एक्सपोनेंट्स. ये ग्रेड 9 के फर्स्ट चैप्टर में तुमने पढ़ा होगा इन नंबर सिस्टम, लॉज ऑफ एक्सपोनेंट्स. And you have studied laws of exponents since grade 7, in 7, in 8, in 9, and in grade 10 basically अलग से laws of exponent नाम से कुछ नहीं होता है, लेकिन इस पे questions बहुत सारे use हो जाते हैं कई बार. तो laws of exponents एक बार यहाँ पे देख लो, उसके बाद कुछ छोटे बहुत questions भी इस पे कर लेते हैं. तो laws of exponents में सबसे पहली चीज क्या होती है, तुमने जो पढ़ी है कि a raised to the power x plus y अगर आपके पास है सो दैट इज इक्वल टू a raised power x into a raised power y, राइट? हालांकि मैंने इसको उल्टा लिख दिया बाय मिस्टेक, लेकिन कोई बात नहीं. a raised to the power x into a raised to the power y over here, राइट? सो यानी कि अगर इफ यू हैव गॉट सेम बेस ओवर हियर एंड देयर इज मल्टीप्लिकेशन साइन, सो यू कैन ऐड द एक्सपोनेंट्स. ठीक है, तो ये चीजें बहुत ही इंपॉर्टेंट, ये क्वेश्चंस में यूज होती हैं. सेकेंड चीज यहीं पे इन लॉज ऑफ एक्सपोनेंट्स यू हैव गॉट a raised to the power x upon a raised to the power y, right? When you have got same bases and there is division sign in between them, so what you do, you have to subtract the exponents, right? So I'm not proving these things. I hope you understand that कि मैं proof इन चीजों का नहीं कर रहा हूं, right? Proof भी कर सकते हो, लेकिन मैं बस रिवाइज कर रहा हूं ताकि तुम्हें समझ में आ जाए. The third thing over here is, and we'll be doing questions as well, right? So if you have got power of power thing, that is a raised to the power x and a raised to the power y. So यहाँ पे तुम क्या कर सकते हो? You can multiply the exponents, right? And you can also change the exponents. तुम इस तरह से भी इस चीज को लिख सकते हो. I hope this is clear, guys. There are other laws of exponents as well. For example, you've got this thing. Suppose a raised to the power x and you are doing b raised to the power x. यानी देखो यहाँ पे bases are different, but there is a multiplication sign in between them, right? Bases are different, but multiplication sign in between them, and same exponents are there. So what you can do, you can multiply the bases and put the same exponent. ये कर सकते हो depending upon the situation. Again देखो मैंने क्या बोला आपको, by name कोई law of exponent नहीं given होगा कि यहाँ पे ये use करो या वो use करो. Obviously you have done these things so as to simplify calculations, right? तो कहीं पे आपको दिखेगा तो आप ऑटोमेटिकली बिना किसी के बताए आप यूज कर सकते हैं इन लॉज ऑफ एक्सपोनेंट्स को, राइट? एंड विल बी डूइंग सम क्वेश्चंस एज वेल, डोंट बॉदर. हेलो शानमुख, वेलकम टू दिस सेशन. ओके, नाउ एक और लॉ ऑफ एक्सपोनेंट ओवर हियर इज दिस थिंग. इफ द सेम थिंग इज गिवन इन डिवीजन, सपोज यू हैव गॉट a raised to the power x divided by b raised to the power x, right? So over here different bases are there, but division is there and exponents are same. So what you can do, you can divide the bases and put the same exponent over there. So basically we are doing over here the concepts which you must do, which must be clear to you before you move on to grade 10 from grade 9. So I hope laws of exponent is clear to you. Obviously you must have done that, but this is a quick revision which we have done over here. I hope this is clear. Hello Anamika, welcome to this session. Is it clear? Any doubt in these things, guys? Tell me. Now there are some more laws of exponents. I mean, you cannot say they are specific laws of exponents only, but they are results basically. Like anything raised to the power 0 is 1, except 0 raised to the power 0. 0 raised to the power 0 is not equal to 1. 0 raised to the power 0 is an indeterminate form. You'll study about it in grade detail when you move on to higher grades. So I hope it is clear. And then you have got nth root as well, which is used many a times. For example, you write like this, nth root. So it means it is a raised to the power 1 by n, right? If you see something, so don't get confused in that. It will be 1 by n power. For example, if you have got something like this, you are writing fifth root of that. It means it is a raised to the power 1 by 5, right? So these things can be used, and these are very important, not only for grade 10, for your life basically, until and unless you are going to do mathematics. Good evening, Sangeeta. Hi, Venki. Welcome to this session. Hello, Chintu. So tell me guys, any doubt in these things? So basically we are doing things which you must know when you are moving from grade 9 to grade 10. And obviously, I mean, these are not, I would not say that it is very grade specific, but this is the most important thing for grade 9 students who are moving to grade 10 right now. I hope this is clear. Now suppose some questions I'm giving on the basis of laws of exponents, some simple questions only. Can you tell me the value of this a raised to the power x minus y into b raised to the power y minus z? I'm sorry, it is not b. I did it by mistake. So it is a raised to the power y minus z into a raised to the power z minus a. Can you tell me the value of this expression using laws of exponents? A raised to the power x minus y raised to the power y minus z, a raised to the power z minus a. Can you tell that quickly? Hi Shanmukh, Anamika, Chintu, Sangeeta, Venki, Sanket. Have you guys done laws of exponents in your previous classes? And can you tell me the answer quickly? So obviously, there are many questions which you can do, but obviously I'll take 1 or 2 questions only, because we are just taking a review of those topics which you must do when you move on to grade 10 from grade 9. So basically over here you see same base is there, and there is multiplication sign in between them. So you have studied laws of exponents, you can add the exponents over here. X minus y plus y minus z plus z minus a over here, right? So over here you see these things will be cancelled out, z minus x, it is not a, z minus x over here, right? So you see this will be cancelled out. Clear? So this is a raised to the power 0, and you know that anything raised to the power 0 is 1, except 0 raised to the power 0, that is not defined. Yeah, that was z minus x. I hope it is clear. Any doubt in this thing? Now I'll ask similar questions, one question over here. It's also a law of exponent question. Suppose if you have got 2 raised to the power x is equal to 3 raised to the power y is equal to 6 raised to the power z, right? So can you find the relation between x, y and z? Can you tell me? What is the relation between x, y and z? If you have got 2 raised to the power x is equal to 3 raised to the power y is equal to 6 raised to the power z. So you can also use something called logarithms, but obviously I'm not explaining these things using the concept of log. Yeah, that was one. Very good. Rakshana, that was one only. You must have done some mistake. Not able to read your name. I'm sorry for that. Opuin. Yeah, that was one, Rakshana. Correct. Now, can you tell me what is the relationship between x, y and z using laws of exponents when you have got 2 raised to the power x is equal to 3 raised to the power y is equal to 6 raised to the power z? Something like this if you have got. Can you tell me the relationship between them? So there is something called logarithms. If you have studied, you can do it, but obviously I'm not talking with respect to those things. I'm just talking about your academic syllabus, your school syllabus, right? So what you can do over here, see they are equal, right? All of them are equal over here. So can I consider them to be equal to k, right? So suppose I take the first equality over here. Can I take 2 raised to the power x is equal to k? Yes or no? Now can I take 1 by x power on both these sides? Tell me. Can I take 1 by x power of both these sides? I can do like that. This is an equality. Now you know that power of power, it gets multiplied, right? Power of power, it gets multiplied. So this will be k raised to the power 1 by x. So basically what are we getting over here? 2 is equal to k raised to the power 1 by x. Clear? 2 is equal to k raised to the power 1 by x over here. In the same manner, if you manipulate, can you not say that 3 will come out to be equal to k raised to the power 1 by y? Can I say something like that? 3 is equal to k raised to the power 1 by y. In the same manner, 6 will come out to be equal to k raised to the power 1 by z over here. I can say like that? Yes or no? So over here you have to establish a relationship between x, y, z, and we can easily do this using these equations over here. See, we know that 3 2s are 6, guys. 3 2s are 6. So you see over here 3 into 2 is equal to 6 over here. Now 3 is k raised to power 1 by y and 2 is k raised to power 1 by x. So I can write over here k raised to the power 1 by y into k raised to the power 1 by this was x, right? And that is equal to k raised to the power 1 by z over here. I hope this is clear up till here. Now you see same base is there and there is a multiplication sign in between them. So you can add the exponents. You can do like this 1 by x plus 1 by y, and that is equal to k raised to the power 1 by z. Now over here you see same base is there and there is an equal to sign in between them. So you can equate the exponents as well. So can I not say over here that 1 by z will be equal to 1 by x plus 1 by y? And this is the required relationship between x, y and z. Any doubt in this thing, tell me. So you can get questions like this. This was just an example, right? Because our motive is not to do laws of exponents only. This was just an example that when you move from grade 9 to 10, these things must be very clear to you, right? There must be no if and but. Please do these things clear as soon as possible because you are having some time in between them. I mean, if you have passed grade 9, like in the last 1 month. I hope it is clear to you. Let us move on to the next thing which we can do over here. So the next important thing is rationalization of denominator. You must have seen rationalization of denominator. It means if you have got suppose a single term, if you have got something like this, you cannot write it like this, right? You have to rationalize the denominator. I mean, sometimes it will not be given in the question, but there will rationalization of denominator will be needed in the question. It will not be mentioned most of the times. You have to understand on your own, right? So how will you rationalize? Over here you see, can I multiply and divide by root 2 in the numerator as well as the denominator, right? Because the thing which you are multiplying over here is called the rationalizing factor. Basically it is making the denominator as a rational number. So basically this is root 2 upon root 2 into root 2 is what? Root 2 the whole square. So root 2 the whole square will be what, guys? 2 only. So you see this is the, over here you have rationalized the denominator successfully. But every time it will not be like that. You will have two terms as well. For example, I am having an expression like this I am taking. Suppose I want to simplify this. So how will you rationalize the denominator over here and what will be the answer after rationalizing its denominator? Can you tell that? Everybody over here must have done this, but you must know how to do it quickly, right? So over here you see two terms are there. So basically, again over here you have to multiply and divide by the rationalizing factor of root 9 minus root 5, right? So basically it will be what, guys? It will be root 9 plus root 5. It will be root 9 plus root 5 over here. So you see in the numerator it will remain as it is 4 into root 9 plus root 5, and in the denominator it is of the form a minus b, a plus b. Because over here you can only rationalize if you do like this. There is no other possibility, right? So the denominator is of the form a plus b, a minus b. So it will be a square minus b square. So that is root 9 square minus root 5 square. So basically it is equal to 4 plus root 9 plus root 5 divided by root 9 the whole square is what, guys? This is 9 only, and root 5 the whole square is 5. So 9 minus 5 is 4, and this will come out to be equal to root 9 plus root 5. So this is the answer. So basically you have to multiply and divide by the rationalizing factor so as to rationalize its denominator. Very good, Gangadhar, that is correct. So I'm just kind of revising these concepts. If you are a grade, you have right now passed grade 9 and you are into grade 10, so these concepts must be clear to you. So I'm giving a question on the basis of this concept. You can tell me the answer. If suppose a is equal to, I'm taking simple questions only, 2 plus root 3. If a is 2 plus root 3, can you tell me the value of a plus 1 by a? Can you tell that, guys? If a is equal to 2 plus root 3, what is the value of a plus 1 by a? The answer would be, no, that was not the answer, Fatima. Root 9 plus root 5 was the correct answer of the previous question if you are talking about. It is root 9 plus root 5, Fatima. Now what will you get over here? If a is equal to 2 plus root 3, can you find the value of a plus 1 by a? So basically over here a is there, can you find 1 by a? So 1 by a will be 1 by 2 plus root 3, right? So again you have to rationalize the denominator by multiplying by its rationalizing factor. Basically in this case it is its conjugate. So it will be 2 minus root 3, 2 minus root 3, or multiplying and dividing. So it is over here 2 minus root 3, and in the denominator automatically it will be of the form a plus b, a minus b, right? So it will be a square minus b square, that is 2 square minus root 3 the whole square. So basically see, this is 4, root 3 square is 3, 4 minus 3 is 1. So 1 by a is equal to 2 minus root 3. This is 2 minus root 3. Now you want to find the value of this. A is equal to 2 plus root 3, 1 by a is 2 minus root 3. So this will get cancelled out. You see over here. So the answer is equal to 4. I hope it is clear. So this is just an example. It is coming out to be 4, Yashita. Exactly, Deepesh, correct. So conjugate term, you can also call its rationalizing factor. So these are the concepts basically. Again, I am saying, Deepesh, I am not explaining the whole thing in very detail. You understand that? I mean, only one class can be taken, or maybe more than one class can be taken on the basis of rationalization. There is something called certs and all that. It's just a revision class, and this is for those students specifically who are moving in to grade 10 from grade 9, that these things are very important. You must revise it, right? They are going to be used forever basically, until unless you are going to do mathematics. So I hope it is clear. Okay, so I had taken so many space for that only, but obviously we are not going to do so many questions on every concept. Now zeros of a polynomial, this is also one of the important things. What do you mean by zero of a polynomial? Suppose I am taking a linear polynomial, a polynomial of degree 1, suppose it is 2x plus 5, right? So what is the zero of the polynomial? 2x plus 5. So zero of a polynomial is the value of the variable for which the value of the polynomial is itself equal to 0, right? So how will you find the zero of this polynomial? You just equate the polynomial equal to 0, right? Equate the polynomial to 0, and then the value of the variable which you will get, that is the zero of that polynomial. You see, x is equal to minus 5 by 2 is the zero of the polynomial. Just equate that polynomial to 0 and then solve it as an equation. So the value of the variable which you will get is the zero of that polynomial. That's it, minus 5 by 2. It's as simple as that. Now this is for a linear polynomial, right? But suppose I am asking for a quadratic polynomial, a 2-degree polynomial. That also you have studied, it's not a very big deal. Suppose I am taking over here this thing. Can you find the zeros of this quadratic polynomial x square plus 5x plus 6 over here? So what you need to do, you just need to equate that polynomial to 0, and then you have to solve it as an equation. So if you want to find the zeros of this quadratic polynomial, just take that polynomial equal to 0 and solve it as an equation. And you must be remembering that in order to find the zeros of a quadratic polynomial, you have to split the middle term. I mean, most probably it will be splitted, but there will be situation, you will study about it in grade 10 only, something called discriminant, that will be less than 0. So in that case, you will not be able to find real zeros of that. So right now I'm assuming that you have just moved to grade 10, so I'm not going into that, right? So let's split the middle term over here. You see this into this, the first term and the last term, the product of them is 6x square. So you have to split the middle term as a sum or difference of two such terms whose product is 6x square, right? So 5x can be written over here as 2x plus 3x over here, because 3 2s are 6, right? So you see, this is the first term, this is the second term. Out of the first term, we can take x as common. So x plus 2 will be left. Out of the second term, we can take 3 as common. So x plus 2 will be left, and that is equal to 0. Now out of the whole expression in the left hand side, I can take x plus 2 as common. So I'll be left with x plus 3. So what you will say, the zeros of this polynomial are x is equal to minus 2 and minus 3. That's it. Zero of this polynomial, they are x is equal to minus 2 and minus 3. I hope it is clear. Very good. Very simple it is. Okay, yeah, Deepesh. Therefore, I was saying this thing is for those students only, right? Okay, now one more concept I would like to say. See, suppose I'm taking a polynomial like this, x minus 1, x minus 2, something like this, a simple polynomial. So this polynomial is having zeros equal to 1 and 2, right? Now my question is this the only polynomial whose zeros are 1 and 2? Can you tell me? Is this the only polynomial whose zeros are 1 and 2? The answer is no, because you can keep anything over here. You can take 2, you can take 3, you can take 4, you can take 5. Any real number value you can multiply over here, and each of those polynomials will have zeros equal to 1 and 2. So therefore, if alpha and beta are the zeros of a polynomial, it does not mean that only one polynomial is possible. Infinite such polynomials are possible whose zeros can be alpha and beta. Correct? Infinite such polynomials are possible. Okay. Now let's see algebraic identities. Algebraic identities are very important when you especially move on to grade 10. These are used. Let me explain these identities, very basic things, but these must be on your tips. The first is x plus y the whole square identity. You know that it is x square plus 2xy plus y square, right? Everybody knows that. Now you see plus minus you can take. I hope you understand that. One time you can take x plus y the whole square, so you'll get x square plus 2xy plus y square. And if you take minus over here, x minus y the whole square, so you'll get x square minus 2xy plus y square, right? So therefore I'm using plus minus over there. So this is the identity. Now the second identity which is useful is x plus y into x minus y, right? So that is equal to what? X square minus y square over here, right? Now one more identity which was useful, just revising these things, guys. I hope you understand that. That is x plus y plus z the whole square identity. So it is equal to what? X square plus y square plus z square. Then you have got 2xy, something like this, 2xy, yz and zx, right? So again I'm saying I'm not taking many questions on the basis of these identities. I'm not taking in fact questions, maybe 1 or 2 question is the product of any real. What is your question, Deepesh? Correct. This over here, now you have got cubic identities over here. Cubic identities which you must remember, which you have done in grade 9 and you must remember it in grade 10. I'm using must because they will be used. X cube plus y cube plus 3xy into x plus y. It will be used anywhere it can be used, especially in the chapter polynomials, right? Now the second one is x cube minus y cube. If you have got x minus y the whole cube will be x cube minus y cube minus 3xy into x plus y. You see, if you have got x minus y the whole cube, it will be x cube minus y cube minus 3xy into x plus y. Now you have got this identity, x cube plus y cube identity. X cube plus y cube is what? This is x plus y into x square minus xy plus y square. So this identity again is very important. Again, minus negative identity is also there. If you are taking x cube minus y cube, so it will be x minus y over here and x square plus xy plus y square. Is it clear? These identities must be on your tips. Rakshana, I hope you understand, because quadratic polynomial, it's a 2-degree polynomial, Rakshana. This was a quadratic polynomial only. This is a quadratic polynomial, Rakshana. This was a quadratic polynomial. A polynomial having 2 zeros is a quadratic polynomial, right? But obviously, I'm not talking about in detail. I hope you understand that, right? That is a different thing. See, we are going to start complete series for grade 9 and 10 on the Infinity Learn class 9 and 10 YouTube channel. From around 10 April, we are going to start the complete series. So you don't have to bother, everything will be there, right? So right now we are doing just for your, just do revision on your own. If you are having any problem, just clear it. We are going to start afresh from 10 April on the Infinity Learn class 9 and 10 YouTube channel, wherein we are going to do everything in detail like we did in the previous session for grade 10 students, right? So we are going to do everything, don't bother. Okay. So this is the cubic identity. Now one more identity which you have studied in grade 9 was x, the biggest identity, x cube plus y cube plus z cube minus 3xyz identity, right? You must have done it. So this is equal to x plus y plus z. This is just for your revision. Again and again I'm saying this is x square plus y square plus z square minus xy minus yz minus zx. Now it's not that, again I'm not saying that this is the only thing which you have to do. You have to do practice obviously. Only knowing these identities, they are not going to help. You cannot mug up these identities. It is never possible. You cannot mug up these identities. You have to practice questions on the basis of these identities. Then only you'll be good at them, right? I hope you understand that. Now some of the things which you must remember in chapter mensuration. Mensuration means what? Surface areas and volumes. In this chapter basically, I mean, it's not just about cubes, cuboids and cylinders. Surface area means for plane figures as well, surface area is used, right? So area basically, not surface area. So very basic things, right? For example, you have got a triangle. So its area is what? Half into base into height. You cannot say that I don't remember the formula to find the area of a triangle, right? You cannot say that. There is no point saying that. So area of a triangle will be half into base into height. And if you have got a rectangle, what is its area, guys? Tell me. Simple figures over here. If it is having length and breadth, so its area will be length into breadth, and needless to say it is area, so it will be square units. If it is area, it will be square units, right? We are not doing questions over here, Dipesh. I hope you understand there is no end to it. I had already said to Rakshana as she was asking, we are going to do a complete series on grade 9 and grade 10 separately on the Infinity Learn class 9 and 10 YouTube channel. You don't have to bother. Exactly. So area of a rectangle is L into B, length into breadth. That's it, right? And if you have got a square, I'm writing over here only. I'm assuming you people already know that, right? So if its side is x, so its area is going to be x square square units, right? And perimeter also you can write. Perimeter of a rectangle is 2 into L plus B, right? And for a square, the perimeter is what? 4 into side. For a triangle, there is no specific formula, because the reason being, for this triangle, I mean, the sides can be anything. So sum of the lengths of the sides is equal to the perimeter of a triangle, right? Okay. I hope it is clear. Okay, fine. What are you saying, Dipesh? The area of the curved surface, is this. Radius and height is fine, the base area and TSA. You haven't mentioned that what is that type, I mean the name of the shape you did not mention of cylinder of cone. Yeah, we'll do that, Pratham, don't bother. Yes. So I hope this is clear. Now there is one more thing, area of equilateral triangle, right? What is the area of an equilateral triangle? It is root 3 by 4 side square. Suppose side is x, so root 3 by 4 side square. I hope these things are okay with you, right? Now there are some other figures as well. Some other figures, for example, you see you have got something like rhombus. You have got a rhombus, right? All sides are equal, and suppose its diagonals are given. Suppose one diagonal is D1, and the other diagonal is suppose D2. So what is the area of a rhombus? Tell me. Area of a rhombus is half into product of diagonals. And all of these can be proved. I'm not saying that they cannot be proved. You must know the proof as well. But obviously I'm not doing it over here. I hope you understand that. The diagonals of a rhombus are perpendicular bisectors of each other. Yes, half into product of the diagonals. Yes. Now there is one more thing, trapezium. Area of a trapezium is what? If you've got a trapezium, what is a trapezium? It's a quadrilateral in which one pair of opposite sides are parallel. So suppose this is A, this is B, and the perpendicular distance between them is given to you. Suppose perpendicular distance between them is given to you, that is H. So area of a trapezium is half into sum of its parallel sides, half into sum of its parallel sides into perpendicular distance between them. Area of a trapezium must be on your tips. You cannot say that I don't remember these formulae. So this is just for your reminder. You can say this session is for your reminder. You have to practice as many questions as possible. If you have got some time left, please take your grade 9 books. Please revise these formulae, revise these concepts, and do practice questions so that there is no problem in grade 10. So area of a trapezium is half into sum of its parallel sides into perpendicular distance between them. So this is the formula, right? Okay. Now there is one thing called Heron's formula, right? When in a triangle you don't have, suppose, base given, or suppose a side is given but corresponding height is not given, then you can find the area of a triangle using Heron's formula. Suppose the length of the sides of a triangle is given, ABC. So its semi-perimeter is A plus B plus C by 2. Semi-perimeter is what? Perimeter of that triangle by 2. Sum of the lengths of the sides divided by 2. So area of that triangle is what? Using the Heron's formula, square root of S into S minus A into S minus B into S minus C. These formulae must be on your tips. You cannot say that I don't remember it. Please practice as many questions as possible. I hope it is clear to you. Okay? So Dipesh asked one question. The area of curved surface is this and the radius and height is this. Sum is this. Find the base area and curve. So, yes, Dipesh, correct. So Dipesh, maybe I'll reply to your question. Area of the curved surface is this. So curved surface area is 2 pi RH, Dipesh. 2 pi RH. Yes. And that is given to be equal to 1848, right? 1848. I hope you understand. I'm not doing calculation all that you can do. And sum of the radius and height is 35. Sum of the radius and height is this. R plus H is 35 over here. So basically you'll get a quadratic equation, Dipesh. I hope you understand, because you see sum of two things you have got and their product you can find. So you'll get a quadratic equation, right? You can get quadratic equation in R and H and you can find it. I hope it is clear to you, Dipesh. Curved surface area is given, 2 pi RH is given. For a cylinder, curved surface area is 2 pi RH, and sum of the radius and the height is given this, so you can find R and H from here. I hope it is okay. Clear? Yeah, so this is the Heron's formula to find the area of a triangle. Okay, now we have got some solid figures of which you must know the formulae. The very first thing is cuboid. For the cuboid, you must know the formula. It must be on your tips. You cannot say any day that I don't remember it, right? So if you have got a cuboid, something like this, if you join it like this. So suppose its length, breadth and height, they are given to you L, B, H. L, B and H, right? So what is its basically volume? Volume of a cuboid is LBH, cubic units. Needless to say, it is volume, so it will be cubic units. Now there is one thing, lateral surface area, or you call it area of 4 walls of a room. Lateral surface area or area of 4 walls if it's a cuboidal room. So that is what 2 into L plus B into H, right? It must be on your tips. I hope it is clear. And then if it is a solid cuboidal room or a solid cuboid, again, surface area is situational. It is not that every time you'll use the same formula. Suppose it is open on the top, it is open on the bottom, something like that, it is open on one side. So it is not fixed. But suppose it's a solid cuboid, its total surface area will be fixed, right or not? That is 2 into LB plus BH plus HL. BH plus HL. It must be fixed if it's a solid. Now there is one more thing, length of the longest diagonal of a cuboid. Many a times you get a question on the basis of this thing. Length of the longest diagonal, I'm sorry for my bad drawing. I hope you understand this point it is meeting. So length of the longest diagonal, suppose it's x. Or you can say the length of the longest rod which can be put inside a cuboidal room. You can prove it using Pythagoras theorem. 2 times you can use Pythagoras theorem. See if you can join it. This is a right angled triangle. So suppose this is y. So in this right angled triangle, y square using the Pythagoras theorem is equal to L square plus B square. Now you see one right angle triangle is standing. I hope you understand that. It is standing. So x square is equal to y square plus h square over here. So L square plus B square is equal to y square, right? So that is L square plus B square plus h square. You are using Pythagoras theorem 2 times. So x will be equal to what? Square root of L square plus B square plus h square. This is the length of the longest diagonal which can be put inside a cuboidal room. Or I can say the length of the longest rod which can be put inside a cuboidal room. This is very important. Yeah, that is correct, Deepesh. Lateral surface area is perimeter of the base into height. That is correct. That can also be seen. So these things are logical. You don't have to mug up them, right? I hope you understand that, okay? Now if you have got a cube over here, suppose you have got a cube. Now cube is nothing, it's not nothing different. It's just a special case of a cuboid. Yes or no? Cube is a special case of a cuboid in which the length, breadth and height, they are equal. So you can write the formula directly. This is x. So what is the volume of a cube? It is edge cubic units, right? What is its lateral surface area? 4 square faces are there. Area of each square face is x square units. So it is 4x square units. Needless to say, I'm not writing in everything over here. I hope you understand that. And its total surface area, 6 square faces are there. So it will be 6x square units, right? And again, the length of the longest diagonal which you can put inside a cubical room, suppose it is y. So it will come out to be square root of, it was L square plus B square plus h square in case of cuboid. So over here it will be square root of x square plus x square plus x square because it is cubical, right? So it will be square root of 3x square over here. So it will be root 3x. So this is the length of the longest rod which can put inside a cubical room. I hope it is clear, right? Now over here the next thing is a cylinder. Yes or no? Again I am saying there is a proof to each of them, but I am not going into the proof of these formulae. I hope you understand that. So there is a cylinder you have got. Suppose we are assuming it to be a solid cylinder only, right? Suppose its radius of the base is r and its height is h over here. So what is the volume of a cylinder? Volume of a cylinder is area of the base into height. This is its proof basically. Pi r square h cubic units. This is the volume of a cylinder. And its curved surface area CSA is equal to 2 pi r h square units. Now one thing I would like to say, see, curved surface area is fixed. Suppose this is cylindrical. Just assume this is cylindrical, almost cylindrical, this pen. If you put it like this, its lateral surface area is changed or not. Lateral surface area is positional. It happens with respect to some position. So lateral surface area will be changing. If you put it like this, lateral surface area is this. If you put it like this, lateral surface area is this. But curved surface area will not change whether you put it like this or put it like this or put it like this. Curved surface area will remain the same. And total surface area is what? It's curved surface area 2 pi r h plus area of the base. If it is there, 2 bases are there, it depends on the situation. It is not hard and fast that it will be there every time. I have seen many students, they use the same formula everywhere. It's not going to help. You have to understand from the situation. It's 2 pi r into r plus h square units, total surface area of a cylinder, of a solid cylinder. I hope it is clear to every student in this session, right? Okay. Now the next thing over here is a cone. These formulae are very important. They must be on your tips. You cannot say that I don't remember it. So if you have got a cone over here, suppose the radius of its base is r, the slant height is L and the height is h over here. So its volume is what? 1 by 3 pi r square h. So you cannot prove this volume mathematically up till grade 10 basically, because something called integration will be used over here. And its curved surface area is pi rl. This can be proved up till grade 10's logic. It is pi rl. Curved surface area is pi rl. and its total surface area will be, obviously its curved surface area, it's pi r L. If it is solid plus area of the base, that is circular base, it is, so pi r square. So it is pi r into L plus r, pi r into L plus r. I hope it is clear to you. And L is the slant height, so you can directly use Pythagoras theorem over here. L is equal to square root of r square plus h square. These things must be on your tips. You cannot say that I don't remember any day in mathematics. It is not just related to your examination. Over here it is not used base area into height, Dipesh. That will be in case of a cylinder. I understood that you are comparing it with a prism and pyramid, right? But this is comparable to a pyramid. So therefore its volume will be 1 by 3 into area of the base into height. I hope you understand. Exactly, you're writing that. But this is not a pyramid, Dipesh. This is not exactly a pyramid. It is wrong if you will say that this is a pyramid, and it will be wrong if you say this is a prism. These are not prisms and pyramids. Prisms and pyramids are polyhedrons. You cannot have curved faces in polyhedrons. Only polygonal faces can be there in polyhedrons. I hope it is clear. The concept can be comparable. Yes, you are right, Dipesh. Concept is comparable, but they are not actually polyhedrons. They are not prisms and pyramids actually. They are not following the definition of prisms and pyramids and polyhedrons basically. I hope it is clear. Okay. Now the last thing over here is the sphere and a hemisphere. So if you have got a sphere of radius r, over here, its volume is 4 by 3 pi r cube. Its volume is 4 by 3 pi r cube, and obviously in a sphere its total surface area and curved surface area, they will be same only, right? It's a sphere. Its complete surface is curved only, needless to say. But the things change when you take a hemisphere. Suppose you are taking a hollow hemisphere, right? Suppose its radius is r. So over here volume will be half the volume of a sphere. So it will be 2 by 3 pi r cube, and its curved surface area will remain the same, that is 2 pi r square. Curved surface area will remain the same, but total surface area will be situational. It will depend on whether it is solid or whether it is hollow, right or not? So obviously when it is hollow, there is nothing in the base over here. So its curved surface area will be equal to its total surface area, that is 2 pi r square over here. But if it is solid, so you have to include the area of the circular base as well. Where it is solid, you have to include the area of its circular base as well. So it will be 2 pi r square plus area of the circular base, that is pi r square. So it will be 3 pi r square as over here. So I hope it is clear. These formulae must be on your tips. You cannot say that I don't remember these formulae. I hope it is clear. And I hope the concept which you are asking is clear to you, Dipesh, right? And actually one more thing is there. I did not remember to write that over here. See, basically one more thing which you can see is area of a sector and area of length of an arc. So if you have got a circle over here, if you have got a circle, and see one arc is subtending theta angles at the center. Suppose length of the arc is L over here and radius of the circle is R, and this is the area of the sector, right? So basically over here as well, length of the arc, you can find length of the arc L is equal to theta by 360 into 2 pi r. The formula is not very strange. Basically it is theta by 360 fraction of the total circle. That's it. This fraction will be theta by 360 fraction of the total length of the circle. Total length of the circle is 2 pi r. You know that circumference of a circle is 2 pi r. So length of the arc is theta by 360 into 2 pi r. And area of the corresponding sector, suppose it is A. So it is again theta by 360 fraction of the area of the total circle. That's it. That is theta by 360 into pi r square. Theta by 360 fraction of the area of the total circle. That's it. Now there is one more important formula which establishes the relationship between the length of an arc and the area of the corresponding sector. That is A is equal to LR by 2. This formula also you can remember. It will save your time many a times. Wait. A is equal to LR by 2. Area of a sector is equal to length of the corresponding arc into radius of the circle divided by 2. Area of a sector is equal to length of the corresponding arc into radius of the circle divided by 2. So these formulae must be on your tips, and obviously the related concepts you have to revise so as to do good in grade 10. From the very start, you have got some time left. Please do as soon as possible. And one more thing, on the Infinity Learn class 9 and 10 YouTube channel, we are going to start a new series for grade 9 and for grade 10 as well, wherein we are going to do maths and science both. Okay guys, bye bye and a very best of luck for your grade 10.